Hey everyone, it's Adam Savage here. Today we're diving into the world of engineering blunders. Buckle up, because some of these mistakes are truly mind-boggling. We're talking about colossal failures, the kind that make you slap your forehead and say, how did they miss that? From leaning towers to collapsing bridges, these engineering disasters serve as stark reminders that even the most meticulous plans can go horribly wrong. So get ready to explore the fascinating world of engineering fails, where we'll uncover the hows, the whys, and the what the hecks behind some of history's most epic miscalculations. You know, I've always been fascinated by the Leaning Tower of Pisa. I mean, it's a tower that literally leans, but here's the thing. It wasn't supposed to be that way. The engineers who built the tower in the 12th century made a critical error. They didn't account for the soft soil beneath the foundation. They started building on what they thought was solid ground, but as the tower grew taller, one side began to sink faster than the other. Talk about a sinking feeling. Now, this is a story that sends shivers down any engineer's spine. The Tacoma Narrows Bridge, nicknamed Galloping Gertie, was supposed to be a marvel of modern engineering, but just 4 months after it opened in 1940, disaster struck. The bridge, known for its unsettling swaying motion, encountered strong winds that caused it to twist and buckle with terrifying intensity. It turns out the bridge's design didn't adequately account for aerodynamic forces, specifically something called aeroelastic flutter. The result? The bridge quite literally tore itself apart, sending chunks of concrete and steel plummeting into the water below. Picture this, it's 1628 and Sweden's most powerful warship, the Vasa, is ready for its maiden voyage. Crowds gather to witness this majestic vessel set sail, but within minutes, disaster strikes. The Vasa, top-heavy due to its excessive ornamentation and gun decks, is caught by a gust of wind and capsizes before it even leaves the harbour. Can you imagine the embarrassment? Years of work, countless resources, all sunk in a matter of minutes because they wanted a showstopper of a ship. It's a stark reminder that sometimes less is more, especially when it comes to naval architecture. Chapter 4. The Mars Climate Orbiter Lost in Translation. Space exploration is fraught with challenges, but this one boils down to a simple yet catastrophic error, a unit conversion mishap. In 1999, NASA's Mars Climate Orbiter was on a mission to study the red planet's atmosphere. However, the spacecraft entered Mars's atmosphere at the wrong angle and disintegrated. The culprit? A mix-up between metric and imperial units in the software used by different teams on the project. One team used metric units, Newton seconds, while another used imperial units, pound seconds, for a critical calculation. This mismatch resulted in the orbiter being off course by about 100 kilometers or 62 miles. Talk about an expensive mistake. Chapter 5. The Hyatt Regency Walkway Collapse. A design disaster. The Hyatt Regency Hotel in Kansas City, Missouri was a bustling hub in 1981. But during a crowded tea dance in the atrium, tragedy struck. 2 suspended walkways, packed with people, collapsed onto the crowded atrium floor below. The investigation revealed a fatal flaw in the walkway's design. A seemingly minor change during construction doubled the load on a critical support rod, ultimately leading to its failure. This disaster highlighted the importance of rigorous design review and communication between engineers and construction teams. Chapter 6. The Hubble Space Telescope, a Flawed Reflection. The Hubble Space Telescope, launched in 1990, was supposed to revolutionize our understanding of the universe. However, shortly after its deployment, scientists realized there was a major problem. The telescope's primary mirror was flawed. A tiny error in the mirror's shape, a mere 2.2 micrometers, about 1/50th the thickness of a human hair, caused images to be blurry. It was a crushing blow for astronomers who had eagerly awaited Hubble's crystal-clear views of the cosmos. Thankfully, NASA engineers devised a brilliant solution. Corrective optics, essentially glasses for the telescope, were installed during a daring space shuttle mission in 1993. Hubble was back in business, and the rest, as they say, is history. Chapter 7. The Chernobyl Disaster, a Nuclear Nightmare. The Chernobyl disaster in 1986 remains a chilling reminder of the devastating consequences of engineering and human error. A flawed reactor design, coupled with a series of operational mistakes during a safety test, led to a catastrophic meltdown at the Chernobyl nuclear power plant in Ukraine. The explosion and subsequent fire released a massive amount of radioactive material into the atmosphere, causing widespread contamination and long-term health effects. The Chernobyl disaster highlighted the critical importance of robust safety protocols and the need for transparency in the nuclear industry. Chapter 8: The Deepwater Horizon Oil Spill, a Gusher of Errors. In 2010, the Deepwater Horizon oil rig in the Gulf of Mexico exploded, killing 11 workers and triggering the largest marine oil spill in history. The disaster was a result of a cascade of engineering failures, including a faulty cement job, a malfunctioning blowout preventer, and inadequate safety procedures. The spill had a devastating impact on the environment and the livelihoods of people along the Gulf Coast. The Deepwater Horizon disaster underscored the importance of comprehensive risk assessment and the need for stronger regulations in the offshore drilling industry. Chapter 9: The Lotus Riverside Complex, a Towering Tumble. Imagine a 13-story apartment building collapsing like a house of cards. That's exactly what happened in Shanghai, China in 2009, when a section of the Lotus Riverside Complex toppled over. The culprit: shoddy construction practices. The excavation of an underground parking garage next to the building weakened the foundation, causing the building to tilt and eventually collapse. Thankfully, there were no casualties, as the building was still under construction. The Lotus Riverside collapse served as a stark reminder of the importance of adhering to building codes and ensuring proper construction techniques. Chapter 10: The Citigroup Center, a skyscraper on the brink. New York City's Citigroup Center is an architectural icon, but in 1978 it was perilously close to becoming a disaster zone. After its completion, engineers discovered a terrifying design flaw. The building's wind-bracing system was inadequate and could fail under certain wind conditions. To make matters worse, the building had been constructed using bolted joints instead of welded joints, making it even more vulnerable. A frantic, secret retrofitting project was undertaken to reinforce the building, with engineers working around the clock to install steel plates to strengthen the connections. The Citigroup Center's near miss is a testament to the importance of thorough structural analysis and the ingenuity of engineers who can avert disaster even after a building is standing tall. Outro: lessons learned, embracing failure, and there you have it, folks. Remember, even the best engineers can make mistakes. The key is to learn from them and keep pushing the boundaries of what's possible. These engineering failures, as catastrophic as they were, have provided invaluable lessons that have shaped engineering practices and safety standards worldwide. So, the next time you marvel at a towering skyscraper or cross a suspension bridge, take a moment to appreciate the ingenuity and precision of engineering, but also remember the importance of learning from our mistakes.